Hey everybody, this is Larry. This is August 9th of 2022. And again, I'm going to try to do another thing. Um, try to do another bonus question. Let me know what you think. Hit the like button, hit the subscribe button, drop me on Discord. Let me know what you think. And earlier today I did do a problem already, but it was an SQL problem. So I'm going to try to do one more, uno más, and one that I haven't done before, and it's in premium because I don't have premium. If you want me to do premium forms, let me know, and maybe you could sponsor it because I'm too cheap to pay for it. Yeah, let's see. No, this is kind of. I wish we could filter these out. Is there a way to filter these out? I guess not. I feel like I look for it every other time, but yeah. I mean, otherwise, this is just really slow grind. Oh, there we go. Okay. So today's problem is count unique characters of all substrings of a given string. Let's define kind of. So example, okay, this returns 5 because okay, given a string S, return the sum of where T is. Okay. This is a hard problem, but some substring can be repeated. Okay. So there can be only n choose two thing, and each one can be at 26. So given that this is 10 to the 5th, this is going to be 10 to the 10 times 26. So it should be, so it doesn't ask you for mod, but I think that this should fit in long. So I think, oh, huh. It's in, oh, I just read this. I missed this. I was wondering about overflows immediately. Is why I kind of did that. But it seems like it fits in 32-bit in, so we don't have to worry about it. Okay. Let's see, right? So the way to think about this problem in general is just about, the way that I would think about it is just about the contribution of this particular thing. How do I do it though? And obviously n is 10 to the 5th, so you can't really do any like crazy things, but you're trying to do it a character at a time. Maybe it takes log n time or whatever, but maybe one way that we can think about it is that for each character, it is the right side of the substring. When this is the right side of the substring, what is the answer, right? Or like how many, what is the sum of all total answer? And then here, the idea is that, okay, maybe we have something like, maybe this is, let's just use the word Leetcode then, fine. Then here, maybe we're up to T, or let's say we're up to O, right? And then here we try to find the sum of OC, TCO, ETCO, and then EETCO, and then this, right? How do we build this? Right now I'm thinking aloud. I'm not really in explanation mode per se, just because I'm still trying to figure out how to solve this. And as you may know, I am solving this live. So yeah. Let's see, right? Well, the thing is that, okay, and O is not necessarily a great example of this, at least in this case. Let's say we have O Leetcode, right? Leetcode spelled in a weird way. So we would try to solve for these things, right? And then the idea here is that we already know the sum of all the previous numbers from the C, because all the prefix is going to be C. So this O is just the number of. So this O is just the prefix of all these other numbers. So it's going to be until you find the last instance of O, right? It's going to be that there's no change in these numbers, and then +1 on all the numbers before the last O, right? So then in that way, I hope that explained it right. But because this O now contributes because of the O in the left. There's no contribution in changes, right? So that's basically the idea, and everything to the right is gonna add 1. So here maybe we'll now construct everything more from the left. So let's say we have L, and then L, because by itself we have 1, right? And there's nothing to the left. And then the second one is E. So what's LE? So LE, we go, yeah. So the two cases, right? One is E by itself, so that's 1, and then LE, that's also another 1. And this LE is just the sum of the previous one. So then here, sorry, this is 2, right? And this 2 is just 1 times all the L, and then now there's the second E, right? And I think I have the idea now, even though I have to be a little bit careful to not make mistakes. But then here we go, okay, what happens, right? Well, E is this, the third E is going to be 1, and then now because E, the last thing, is over here, then we just, you know, almost copy and paste kind of way. You know, we just but here we reuse the 2 and the 1 because the last E is, you know, right next to it, so that's a little bit weird. The next one is O. Of course, O is 1, and then you just almost, like I said, copy and paste again all these numbers. We add an O, and because O is a new thing for each of them, this is going to be 3, 2, 2. And then we just keep track like this, and I think we're okay. We just have to figure out what is the last element, and then do some maths based on that. Yeah. And then, like I said, dot, and then, yeah, I think this is okay. Like I said, the actual implementation we just have to be careful about, but it should be good. We just have to do the maths, right? So maybe we have something like, okay, count is equal to 0 times n, where n is the length of S. And then now we have for I in range of n, or maybe, yeah, maybe that's fine. And then we maybe keep a variable name of like last is equal to some lookup table, and this just keeps last instance of this character. Or last sub C is the previous instance of C, or something like this, right? And then we can go like S of I is the last character. If this is in last, or if this is not in last, maybe doesn't matter. So let's just do this one case because I know how to do it. If this is not in last, then this is literally just counts of I minus 1. So because if it doesn't exist, that means that for each of these previous word, it's just times, you know, you add 1 character for each of them. So it is the previous case plus I, is it plus I or I plus 1? Yeah, I think it's I plus 1. And the I plus 1 is basically from includes the case where, you know, you're in the ith index. If you're in the second index, for example, here, you well, maybe not this particular case because it has the same prefix, but if you're in the second index, that means that there are 2 previous one and then the current one with 1 character. I think this is it. Yeah. So count of I is equal to this. If I minus 1, you can maybe also create a send note here, but it's fine. Else you go I plus 1, which means that if this is 1, yeah, this is just 1 otherwise. And then we set last of S of I is equal to I, right? And then else, if this is in last, then we just have to split it into 2, right? So here, how do we split into 2? So last sub S of I is equal to the previous index, say, right? And we could probably take this outside because we want to reuse this later anyway. Let's say this is the previous index, so then inclusive of the previous index, we do not add 1, right? So that means that count sub I is to go to count sub previous plus so then how do we, so here it's almost like a prefix sum in that, let's say there's a 0, you want to get to the previous, so then you add 1 on the stuff here, right? So that means that you add, I mean, you could do that. I think the formula actually is a little bit funky because you would do in a prefix sum kind of way, count sub I minus 1 plus this, you know, I plus 1, or, you know, this is, but this is not a prefix sum, so this is this minus count sub previous. So, and if you can, you know, and this is like a prefix sum kind of way, meaning that this is the sum of all these numbers minus the sum of the prefix, like I said, prefix sum. But as you can see, and as I was kind of working out in my head, if you kind of saw that for a second, that these two cancels out. So that means that we can actually just do, so this is actually exactly the same, huh? Is that right? That just feels so funky. Or maybe I'm off by 1. Oh, no, okay. This is that part is the same, but I kind of skipped ahead. This is an I plus 1 because now you only add 1 contribution to the stuff that's before. So it's something like I minus previous plus 1. Okay, that's why. But here, these two cancels out. Because I was like, that doesn't make sense. Maybe I'm off by 1, but I think that's roughly the idea. Is that given I've index, and then you subtract the previous. And I think that's good. And then now at the very end, you return sum of the counts. And I think either we're off by 1 or we're very close. So I think that's pretty much the idea, though. Maybe a very wrong idea, but I think this is off by 1 because the unique one is okay. And maybe we can even try some other unique things just to kind of show that it's okay. But it's just the it's just this thing. So this is probably off by 1. This is too much, I guess. Huh, that didn't solve it, huh? Okay. This is just me being lazy, so give me a second. So this plus 1, okay, so I minus 1 is the number of counts in, let's see, let's say I is 1, 2, 0, 1, 2, 3, 4, 5, 6. Yeah, so the index is 6. And then this will be 6 minus the previous index, which is 0, 1, 2, 3. But that includes that 4 number. So this is this minus this plus 1, which is this minus 1. Yeah, and then I... is this right? Am I just being lazy and funky and that? Okay. Let's see. Let's print out counts. Huh, this is very weird, but... Well, this 3 is weird, right? Because they should at least have 1 extra... Oh, no, I mean... Yeah. This should at least have 1 extra thing, so maybe this one is wrong. Because I think... I thought that was wrong and that there's minus 1 and plus 1 for itself. But why is that wrong? So, okay. So this is wrong for ABA. Oh, did I misread this problem? Why is count of this equals to 1? Oh, I did misread this. Well, now you saw, I thought this is the count of unique characters as in, okay, so okay, so this formula is right, it's just that we solved the wrong or different problem, and that this is the count of unique characters that, I didn't read this example. I counted the number of unique characters so that ABA would return 2, but not the number of characters that are unique. I think the idea is the same, but we have to make some modification. Meaning that now, when you get to the last, so I think this is still right, because if you don't see anything, then it's just the previous count plus the current count, which is unique, right? But if you do see one, then you just cut it off. So that means that this is actually very prefix summy of this minus counts the previous or something like this. And the idea behind here is that once you go to the left of it, wait, no, it still should be right. So that means that once you, no, wait, let me think about this. I mean, the idea is going to be the same, though we clearly did it incorrectly. But so this is 2. This is, oh, this is going to be this minus, well, this is just 0, and this is 1, right? So then here, and this is also 1. So here we take this minus. Okay, so I think the formula is roughly the same. So okay, so we didn't really, I mean, we did obviously solve the wrong problem, but it is something that we can fix, right? So then that means that this is, you know, now this is 101, and then we added the 0. This is now 212, right? So then here the idea is that once you pass the previous, you have to uncount this number. So then now let's figure it out a little bit. Let's remove this. So the stuff that is to the right, or I say to the right, but all the stuff of none before or after, after the duping, it is going to be this amount. Yeah. So this is the amount to the not dupe, and then the dupe elements is going to be counts of previous minus previous, something like this, right? It may be off by 1, but the idea here is that to everything to the left of it, because this character, now you have to do some inclusion exclusion thing actually, so that's what makes it tough. I can't do this quite like that, but that you have to basically adds in the previous instance of this, because for example, if you have like L E, let's just say 3 E's. In this case, you know, this is equal to, we can't just be like, okay, this is equal to, you know, 1 E, which is what we have here on top, but then you have to subtract it from, you know, L E, and then an extra E, and this is before we can't just subtract this minus 1 from here, because here we already have double E, so it doesn't, so we don't subtract, right? So wow, this is a hard one. I mean, I think that's fine, but I don't think that, yeah, I think that's fine, because we just it's not a full exclusion inclusive exclusion inclusion principle, because I think now after going 2 previous ones, we can we're good. Yeah, so then we do this, and then we maybe so how do I say this in a good way? So this is the no dupe part, there's the dupe part, and then we want to subtract out the dupe part, right? So it will be something like this, minus counts of previous well, we add it back in, and this is not the count, this is just that for stuff before that. Is that true? Give me a second. Maybe this is the wrong way. Let me think. Because here this assumes that we subtract all the stuff until the last one, but that only assumes that we haven't had a dupe. No, I think that's fine. I think this past the second dupe, I think, yeah, adding back in the second dupe means that we add in the values before that. Because here we subtracted too much. I think this is okay, but we have to keep track of the previous. So yeah, um, hmm, hmm, maybe last has something like this, and then here. And then this is fine, I think. Keeping in mind that this could be none, but yeah. I mean, I wrote this wrong. Hang on. Something like this. Let's see. Let's give it a spin. Uh, oh yeah, because this is not. Whatever. Fine. I guess I don't need this. Oh man, why did I write it so weird? Okay. So this is still the wrong answer, but hopefully this is slightly better. We can, I mean, way potentially is off by one. So, yeah. Let's see. Right. So we're still outputting too much, but ABA, what is ABA? We can do this manually and then check this answer that we are, yeah. Okay, ABA. All right, let me erase this. So ABA, we have A is equal to 1, and then now we do the B. We have B, AB and B, so we have 2 and 1, and then now we have ABA, which yeah, for this A, we have BA, which is 2, and then A is equal to 1, and then this is also equal to 1, right? And the way that we kind of look at this then will be that we don't subtract correctly, maybe. So this is previous. I was a little bit lazy on this formula, to be honest. So yeah, so previous is going to be 0. So this is minus 0, which is not right? It should be this. It's this plus 1 because we want it be inclusive of the previous. Okay. So this fixes this part, but it's still wrong for this part. And that is possibly what number? Leetcode? Oh yeah, the third ye is probably why. Yeah. Oops. Maybe I should have done this. Or like erase the Leetcode, because then now we can check real quickly. And there's another way that we can actually check pretty directly as well. But yeah, but this is previous. So I think we have to add in 1, maybe no. Because we have to get rid of, yeah, because previous is 1, so we added 1, but it should be 2 because of LE prefix. Yeah, this looks okay for now, but let's try a number thing where we have multiple, even more ye's, so that we don't check that. Okay, so that looks good. Let's see. Okay. Okay. So I mean, now I'm confident just because if it works for that thing, it probably is okay. Unless I missed something like really obvious. Let's run it one last time without the print statement. So yeah, let's give it submit. But this is a pretty tricky problem to get right. Wow. I mean, this is going to be linear time, linear space. Linear space is unavoidable. Well, at least the way that we did it. But there's three things of linear. Oh, I guess not. This is linear space for sure. But these two are actually all of alpha, where alpha is the number of alphabet. And this is going to be linear time, just, but everything in here is all of one. So, so linear time, linear space, and that's pretty much all I have for this one. Even though I kind of solved the wrong problem, and you kind of could see it, but hopefully that you see that I work it out by just, because here, I think this is the part that I kind of maybe was a little bit skimming on explanation, but this part is everything that we talked about with that. This is the dupe part, but this is the dupe part, and what I mean by that is that, let's say I have, I don't know, bananas, say. Bananas has a lot of A's, right? The idea here is that we have A, and we want to subtract, we go to NA, A to NA for this part, just the no dupe part, right? And then here, this part is the dupe part, which will contain BA, NA, but then here, and so the counts of previous is the count that are here, but we want to subtract out this because, when we add an A, this A cancels out these A, right? Cancels out all the prefixes on here, but the problem is that we want to put back in the BA, because when we subtract from the prefix, then this number subtracted too much because we also subtracted from A, but that means that this A already subtracted from this A before, right? Because you don't want this A to subtract from, so that's basically almost like a inclusion exclusion, but not quite. Hopefully that makes sense. Let me know what you think. Let me know your your questions and comments and whatever. That's all I have. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Yeah, fun problem, eh?